compound circuit problem, the same steps will still apply. You still would like to find the overall resistance of this circuit, the equivalent resistance of the circuit. Except you're going to handle this in parts. I recommend finding the total resistance of the circuit first by finding the parallel part. So the REQ of the parallel part, which would be this part of the circuit. So a 5 ohm and a 10 ohm in parallel we have just solved before and found that that total equivalent resistance, which is 1 over REQ is equal to 1 over 10 plus 1 over 5. This is equal to, when I solve it all out, 3.3 ohms. This means that I could take that parallel part and I could collapse it down and replace it with a 3.3 ohm resistor in series. It would be the same as taking that whole part that I put a red box around and replacing it with a 3.3 ohm resistor in series. So if you'd like, you can write 3.3 ohms in the middle of this, because then that will allow you to think about the total resistance of the entire circuit. For the time being, I have only solved the total resistance of the parallel part. Resistor in series. So the two series resistors added together, 3 plus 3.3, will give me the total resistance for the circuit, which would be 6.3 ohms.
So you just add them together?
Yep, because now it looks like they are in series with one another. Questions? From here, I can use the total voltage to find how many total cars, how much current is going to be on the road. So I know my voltage total is 3 volts. I know my REQ is 6.3 ohms, and I can get the total current, which when you calculate it out should be in total 0.47 amps.
You use the total.
So that is equal to VER, V equals I times R.
You use 6.3.
Yes, I use 6.3 for the R, and I solve for I.